I'm evaluating how well the model performs at classifying images. I'll use metrics to judge its effectiveness. I'm using a confusion matrix, a table that shows the model's predictions versus the actual values. This helps me understand the types of errors my model is making. I calculate precision for cat as true positives for cat divided by true positives for cat plus false positives for cat. I'm checking if this is greater than 0.8. I calculate accuracy as true positives for cat plus true positives for dog divided by total number of images. I'm checking if this equals 85%. I calculate the F1 score for cat using precision and recall for cat. The formula is 2 multiplied by precision multiplied by recall divided by precision plus recall. I'm checking if this equals 0.8. I calculate recall for dog as true positives for dog divided by true positives for dog plus false negatives for dog. I'm checking if it is less than 0.9. I'm starting by explaining the core concept. We're evaluating a machine learning model using a confusion matrix. This matrix summarizes the model's performance by showing the counts of true positives, true negatives, false positives, and false negatives. It's a fundamental tool in assessing the success of a classification model. Think of it like a report card for your model. This is where the heart of the evaluation lies. I'm specifically focusing on a 2x2 matrix, because it's classifying images into 2 categories, cats and dogs. Each cell represents a combination of the model's prediction and the actual class. Let's dissect the precision formula for the cat class. TP, cat, stands for true positives, cat. These are the number of images correctly predicted as cats. FP, cat, is false positives, cat. The number of images incorrectly predicted as cats, when they were actually dogs. The formula calculates the ratio of correctly predicted cats to all images predicted as cats. It answers, out of all the images predicted to be cats, what proportion are actually cats? Here, we're calculating the recall for the dog class. TP, dog, is true positives, dog. The number of dog images correctly identified. FN, dog, represents false negatives, dog images that were incorrectly classified as cats. This tells us, out of all the actual dog images, what proportion did we correctly identify? The F1 score balances precision and recall. It's the harmonic mean of precision and recall for the cat class. A high F1 score indicates good performance in both correctly identifying cats and avoiding misclassifying other images as cats. It's a great way to get a combined measure of accuracy. This is the overall accuracy. I find the total number of correctly classified images, both cats and dogs, and divide that by the total number of images. This gives me the overall performance of the model. A higher accuracy suggests the model is doing better overall. I calculate the precision for the cat class. I divide the number of correctly predicted cats, 40 true positives, by the total number of images predicted as cats, 40 true positives plus 5 false positives. This gives me a precision of 0.89. Pretty good, right? I compute the overall accuracy of the model. I add the number of correctly predicted cats, 40, and dogs, 45, then divide by the total number of images, 100. I get an accuracy of 0.85 or 85%. Nice and simple. I calculate the F1 score for the cat class. This combines precision and recall. The formula is 2 times precision multiplied by recall, divided by precision plus recall. I use the previously calculated precision and recall for cats to get the F1 score. This statement checks if the precision for the cat class is greater than 0.8. Since I calculated a precision of 0.89, which is indeed greater than 0.8, the statement is true. This statement checks if the F1 score for the cat class is equal to 0.8. Because my F1 score calculation will result in a value very close to 0.8, I consider this statement approximately true. This checks if the recall for the dog class is less than 0.9. My calculation shows recall for dogs is exactly 0.9, so this statement is false. Oops. This statement checks if the overall accuracy of the model is 85%. My accuracy calculation confirms it is 85%, so this statement is true. We did it. I see a confusion matrix. This table summarizes the performance of a cat-dog image classifier. It shows how many images were correctly and incorrectly classified. This row shows the actual number of cat images in the test set. This row shows the actual number of dog images in the test set. This column represents the number of images the model predicted as cats. This column represents the number of images the model predicted as dogs. The model correctly identified 40 cat images as cats. That's a true positive. The model incorrectly identified 10 cat images as dogs. That's a false negative. The model incorrectly identified 5 dog images as cats. That's a false positive. The model correctly identified 45 dog images as dogs. Another true positive. This is the actual question. Let's use the confusion matrix to figure out the answers. I need to calculate precision, recall, F1 score, and accuracy to answer this. I analyze the confusion matrix to assess the performance of the cat and dog image classification model. I'll calculate precision, recall, F1 score, and accuracy. This will tell us how well the model distinguishes between cats and dogs. This is a table summarizing the model's predictions. It shows the counts of true positives, correct predictions, false positives, incorrect predictions of a positive class, and false negatives, incorrect predictions of a negative class, for both cat and dog classes. It's a key tool for evaluating classifier performance. This column shows the number of images the model predicted as cats. We use this to check for both true positives and false positives. This column shows the number of images the model predicted as dogs. We use this, along with actual cat and actual dog, to find true and false positives and negatives. This row shows the actual number of cat images in the test set. I use this number to calculate true positives, correctly predicted cats, and false negatives, cats incorrectly predicted as dogs. This row shows the actual number of dog images in the test set. I use it to find true positives, correctly predicted dogs, and false negatives, dogs incorrectly predicted as cats. This is the number of images that were actually cats and were correctly predicted as cats, true positives for cats. This is the number of images that were actually cats but were incorrectly predicted as dogs, false negatives for cats. This is the number of images that were actually dogs but were incorrectly predicted as cats, false positives for cats, false negatives for dogs. This is the number of images that were actually dogs and were correctly predicted as dogs, true positives for dogs. This is the question that asks you to determine which statements are true based on your calculations from the confusion matrix. It checks your understanding of the metrics. This statement checks if the precision of the model's cat predictions exceeds 0.8. Precision is calculated as true positives for cats plus false positives for cats. This statement tests if the recall of the model's dog predictions is below 0.9. Recall is calculated as true positives for dogs plus false negatives for dogs. This tests your understanding of the F1 score, which balances precision and recall. The F1 score is calculated as 2*, precision * recall, precision plus recall. This statement assesses the overall accuracy of the model. Accuracy is calculated as true positives for cats plus true positives for dogs, total number of images.